Well, one of our consequences of dealing with integration by substitution was that we could actually now come up with a general power rule for our integrals, which is a counterpart to our general rule for derivatives. You recall that in the general power rule for derivatives, the derivative with respect to x of some function u to the n would be n times u to the n minus 1 power times the derivative of u with respect to x. Well, on the other end of it, if we're taking the antiderivative, that is the indefinite integral of u to the nth power du, where u is a differentiable function of x, then our integral would be 1 over n plus 1 u to the n plus 1 power plus a constant, of course provided that n is not equal to negative 1. If it is, we'll just use a different rule. All right, so here's an example of that. If we let our expression contain u to be the quantity x squared minus 3, then we would certainly find that du would be 2 times x dx. And properly rewriting our integral, we're going to have 1/2 of the antiderivative of u to the third times du, where du is going to be our x 1/2 of du will be our x times dx. And of course, that's going to give us 1/2 times our integral of u to the third, which is going to be 1/4 of u to the fourth. Right, there's our general power rule, plus the constant. And then finally we can go back and simplify one more time by rewriting this as 1/2 times 1/4 1/8 times our quantity u, in this case x squared minus 3 to the fourth power plus a constant. Another example right here, we have u. In this case, we could set u equal to our quantity in the denominator there. Let's call it x squared plus x. And right away, we can see that its derivative du does already manifest itself up here in the numerator. We've got 2x plus 1, that quantity times dx. And recognizing that is going to allow us to rewrite this expression as the antiderivative of du divided by u squared, or stated another way, the antiderivative of u to the negative 2 du. You'll notice we didn't have to do any adjustment with our constant right here. So now if we use our antiderivative rule, we're going to have 1 over negative 2 plus 1, so that's just negative 1. U to the negative 2 plus 1, there we go, that's negative 1, plus our constant. So our expression will look like, when we replace u and simplify, 1 divided by the quantity x squared plus x raised to the first power plus our constant. So we're done with this particular nice example using this general power rule for integrals.